Hi. So for problem set 6, I chose to go over problem number 3. So it reads, write out a complete proof that the square root of 3 is irrational. So based on the premise or the conclusion that the square root of 3 is irrational, you can build an indirect proof that is actually taking the conclusion as a negated premise. So starting with the negated premise, you'd say that the square root of 3 is rational, and the definition of a rational number being that n equals p divided by q, such that p is an element of integers, q is an element of integers, and that q does not equal 0. So beginning with the proof here, you say you set n equal to the square root of 3. And that you can also square that, and then find that p over q would be in that form. Square root of 3 would be p squared over q squared, which would equal 3. Therefore, p squared equals 2q. Therefore, p squared is an even integer, and p, based on that, is an even integer based on some formulas we've gone over before. And so now 4 is a factor of p squared, which would mean that q squared is even and that q is even. So this goes against the definition of a rational number that they share a common factor besides 1. So the final conclusion being that p and q share 2 as a common factor, which is a contradiction to the definition of what a rational number is, therefore disproving the original negated conclusion as that was the premise, and proving that the square root of 3 is irrational.